All right, so let's go ahead and check out our lesson here for section 5.4, and I'm going to write this up here too. So this is 5.4, and we are dealing with special solutions, special systems of linear equations. Should have wrote this out before, but oh well. Okay, so chapter 5.4, and we're looking at special solutions. All right, so like I have wrote up here, this graphic's also in your book, but so our first option is one solution. This is what we've been working with so far, and one solution is going to be lines that intersect. Okay, they intersect one time, and it doesn't matter what the angle is, as long as they just intersect once. So it's going to look something like this in the graphic there. Okay, our second option is no solution. These no solution problems are going to be lines that are parallel. So they have the same slope and they run parallel. They are never going to intersect, hence there's no solution. Because remember, that solution is that intersection point of the two lines. And then our last option is infinite solutions. And these are going to be solutions that occur when the line is the exact same. So it's just going to look like one line because one line lies on top of the other line, and they're going to intersect through infinity. So any number, any coordinate that you plug in is going to work for both equations for any single point on the entire number system from negative infinity to positive infinity. Okay, example 1 we're going to look at is no solution. Okay, this one, we have equation 1 is y equals 2x plus 1. Equation 2 is y equals 2x plus 5. Okay, we can solve this a couple of different ways. We can solve it first by graphing. So I can take my coordinate plane here. Remember, we're going to graph our y-intercepts first, and then we use our slope to find the next point. So this line has a y-intercept of 1. I draw that point there, and a slope of 2. So I need to draw out my points. And it helps if you draw it basically these dashes, if they're the same spacing for the x and y axis, it's going to make it a lot easier, and we're going to have a more accurate line. So that's really what you have to focus on, is getting those dashes about evenly spaced for both axes. And then we take our slope of 2, go up 2, right 1, okay, up 2, right 1, up 2, right 1. So it's going to look something like this, okay? And then my next line has a y-intercept of 5. 1, 2, 3, 4, 5. And we're going up 2, 1, 2, over 1. Up 2, over 1. And if I actually drew this straight, these would be parallel, okay? And I mean, you can get the gist of it from there. Okay, so these are two parallel lines, which means there's going to be no solution like this one I have right here. And you could have seen this also by the slope. So they're both in y-intercept or slope-intercept form, and they have different y-intercepts, but their slope is the same. So if you remember back from chapter 4, lines with the same slope are going to be parallel. So it's just the same line, but it just got moved up 4 units. Okay, so this is an example of no solution. Now the second way I can solve this is by substitution. So what I'm going to do is I pick one of these and I'm going to plug it in. So if y equals 2x plus 1, I'm going to go ahead and substitute this in for y down here, get everything in terms of x. Now when I do that, I get 2x plus 1 equals 2x plus 5. And then I move the 2x over, and those cancel out on both sides, so I get 1 equals 5. 1 equals 5 is not true, okay? So that means that we have no solution, okay? Because when we solve by substitution, we have to get some sort of an answer, like an x equals something or y equals something. If the variables cancel out, then it's going to be no solution, because that means you can't plug in any number. Any number you plug in is not going to work. Okay, so we had two x's, and you can see that right off the bat. If I have the same variable on both sides with the same leading coefficient, 2x and 2x, those are going to cancel out. So you can even notice earlier on before you actually solve it out. Okay, so this is no solution. Example, and I did it two ways, one by graphing and one by substitution. Okay, and that was no solution. So those lines were parallel and they never intersected. My next example is one with infinitely many solutions. So example 2 here is going to be infinite. I'm just going to write, okay, infinite solutions. And my example here is negative 2x plus y equals 3, and negative 4x plus 2y equals 6. So I got these two equations, and now, since we solved once by graphing, once by substitution, I'm going to solve this one first by graphing and then by elimination. So if I graph it, I need to get all of this in terms of y in slope-intercept form. So let me rewrite this. So y is going to equal 2x plus 3, and then if I solve that one, I get 2y equals 4x plus 6, divide by 2 from everything, and then I get y equals 2x plus 3. So you notice those are the same lines, so I'm going to graph it anyways, but if you can tell from there that they're going to be the same line, then you can just go ahead and already put infinite many solutions. But if it does say to graph, then go ahead and graph it, but just know it's going to be the same line. So I'm going to plot this y-intercept point there at 3, and then I'm going to use my slope of 2, go up 2 over 1, and just draw the line like that, and then just draw the other one that is just going to overlap it because it's the same line. Okay, so that is infinite many solutions because the lines lie on top of each other, so every single point on one line is going to be also on the other line. Now, I could solve this by substitution by taking this, plugging it in for y, and I'm going to get 2x plus 3 equals 2x plus 3, and everything's going to cancel out because it's all the same. So I would get 0 equals 0, which is going to mean infinitely many solutions. Now I'm going to solve it by my last way of solving a linear system, and that's by elimination. So I want to multiply this number here by, multiply it by negative 2. Yep, so all this times negative 2, because I want to get this thing to be a positive, so the x's will cancel out. When I do that, I get 4x minus 2y equals negative 6. And then on the bottom, I have negative 4x, because this one stays the same. And I get negative 4x plus 2y equals 6. Notice everything's opposites, so they're all going to cancel out. That goes to 0, that goes to 0, that goes to 0. 0 equals 0. And so this is going to mean infinite solutions. Okay, no matter how you solve this, you're still going to get the same answer. So depending on, some may say solve by graphing, some may say elimination, some substitution. Solve it whichever way, but no, if you get on a graph, if you get it lying over top of each other, that's going to be infinite solutions. If they're parallel, then there's going to be no solution because they never intersect. If you are solving using any of the other methods like substitution or elimination, if you do that and you get like 1 equals 5 like we did in the first example, and you get a number equals another number that's not true, 1 does not equal 5, so it's not true, then that means there's going to be no solution. Okay, and then if And then if you get, like what we did here, if you get one number equals another number that's true, 0 equals 0 is true, then you're going to get infinitely many solutions. So those are the things to look out for, and you can go ahead and work through at least maybe a couple of those on the monitoring progress if you want before you come to class. Don't forget to take some notes. I would definitely probably write down this one we've already went over, but these two are our two focus, so no solution and infinitely many solutions. So write those two down, make sure you know when it's going to be no solution or when it's going to be infinite solutions, and then you'll be fine here for lesson chapter 5.4, and then we'll go ahead and hit the homework here next class. Okay, so thank you.